Hello everybody, we're getting ready to do lesson 1.7 for Algebra 2, complete the square. This is my contact information. 1.7, complete the square. We got 26 points here for your skill sheet at the end of part 1. And then we have 13 points here of note-taking. Here is your bell work, students. Write the expression as a complex number in standard form. So there you go there, and then write the expression as a complex number in standard form. These are extensive problems, teachers. I give my students 6-7 minutes to do these two. And then here's the solution for number 1 here. We have to rationalize our denominator here, and we come up with this here. You have to use a conjugate here. So we multiply everything by c plus di over c plus di. This rationalizes our denominator. Then we come up with this cdi minus cdi minus d squared I squared. And then we factor out a negative d squared here, which is positive actually. The I squared becomes negative 1, and then the d squared is here. And then negative d squared times negative 1 would be positive d squared. And up here we have two binomials. And see, AC plus BD. Then we go ahead and we divide these up here into two different quotients here, with this one being I. So this would be a complex number here. This is rational, and then this is imaginary over here. And then same thing here, students. This is what you should have done with yours here. And you end up with this down here with a complex number where you have this is a rational number, and then this would be imaginary here. Okay. So before you solve quadratic equations by finding square roots, so now we're going to complete the square to solve, or rather to factor trinomials. So previously you have solved equations like this, x squared equals k, by finding square roots. This method also works if one side of a perfect square trinomial. So, for example, solve a quadratic equation by finding square roots. So we're going to use the square root method here to solve this. X squared, we have this trinomial here. So we can go x minus 4 squared equals 25. So this is a perfect square over here. And then we have a 25 over here. So take square roots of each side, and this is what we end up with here. And then x would equal 4 plus or minus 5. That'll give us two solutions here. It would be 9 and negative 1 will be the solution to that trinomial. Solve the equation by finding square roots. For this one, students, this is on you. Watch as we solve this one, so you can use it for your independent practice. So we have this here, this trinomial here. This is a perfect square, and then this over here is hanging out. So what do? We take radicals on both sides here. Then we have x equals negative 3 plus or minus 6. And then that turns out to be 3 and negative 9 to be our solution for that. Perfect squares, in example 1, this was a trinomial, is a perfect square because it equals this. Sometimes you need to add a term to an expression, x squared plus bx, to make it a square. This process is called completing the square. So students, this is your chance to define completing the square in your own words. Teachers, give your students about 3 minutes for that. Okay, so a key concept here about completing the square. To complete the square of this expression here, add b over 2 squared. So the diagrams, in each diagram down here, the combined area of the shaded regions is x squared plus bx, x squared plus bx. by adding b squared over 2, complete square. So we have x squared and bx, so 1/2 bx squared. So we have b squared here, b squared, and then b squared here. So that's the idea, because you're removing this, so now you have this space here to fill. So when you remove that and stick it underneath here, it makes a perfect square. So here's the algebra for that, ax squared plus bx plus b over 2 squared. And then here is our perfect square here equals x plus b over 2 squared. So make a perfect square trinomial. We have a trinomial here. Then write the expression as a square of a binomial. So find a half coefficient of x, so 16 over 2 equals 8. And then square it, and we get 64. So, do next. Replace c with the result of step 2. So we x squared plus 16x plus 64. And then, so x squared plus 8x, and then we chop this in half. And we put it here, and then we put it over here. Chop this half, stick half of it here, and then the other half here. And we come up with this, x plus 8 quantity squared. Okay, so for here, let's make this a perfect square. Students, you do this as well. So for here, for 14x, we take 1/2 of 14 and square it, which is 49. So now we add that over here, x squared plus 14x is 49, and we come up with these two binomials here, x plus 7 squared. And if you need more PowerPoints, video, online tutoring, etc., contact me here and I'll take care of it. Thank you.